guys, I'm Ashwin and I make videos on tech related topic. And yeah, as you seen in the thumbnail, we are going to start a new series on this programming language called Rust. And yeah, we are planning to do this particular video on giving a small introduction about the Rust and history of Rust and how this programming language stand out from all other languages that are available in the market, which are also called. So without any delay, we can dive into this programming world. And yeah,
So hello again, and as we told last time, we are going to dive into the first section of this introductory part of the Rust programming language. And yeah, I know this language is very hard to learn. It has some hard learning curve, but trust me, guys, this is the language that going to outbreak in the next upcoming years because of these unique features on memory and low level structure, and it is highly compatible with C and CPP, but we can do more than what this language, I mean C and CPP can do. So of course, if you take your phone out and just Google it like top outbreaking language that going to happen in the upcoming years, and in the top four list, I bet you guys it will be one will be in the Rust programming language. So there are many reasons, and I will be covering in the upcoming videos about all that. And yeah, today is all about just going diving into the history of Rust. How this there's an interesting I forgot there's an interesting story behind the development of this Rust programming language, and how the unique features of Rust that make all of other languages. And yeah, that's it. We can just go to the sections. And yeah, this is the first one, history of Rust. So yeah, this is the story I am going to talk about. Yeah, we know the in 2016, Graydon Hall was developed this language as a personal project, and the motive behind him to develop this kind of language was an interesting story. So he was an employer or he was a developer at Firefox, and yeah, I guess you all know about Firefox. And when he coming from office to home, he has to deal with a bug in his life, and he has to climb all the way to the up of the what will we say apartment, as the lift was not working at that time, and it was a regular problem to him, and it made him some frustrations and all. So as when we think from our side, what will we going to do when we find this situation? I mean, we are paying for that apartment and we can't able to use the lift because of this error, and we have to climb every day after doing some work. And what will we do? Of course we will going to shout at the security guard or whoever responsible for doing this mess. And in case of Grant Hall is an interesting man, and believe me, he just started to blame on himself. Guys, do you believe it? Yeah, he just his thinking process was like, oh man, even with this developer, I mean, with this high profile developing, and I have a job in Firefox, I can't even fix this simple lift problem in my life. And he was so started to blame himself for that, and he started to solve or find a solution for that. That was the mentality of him. The mentality of him, guys, and this mentality literally paved the way of the development and introduction to this programming language called Rust, and it is going to be get more popular in upcoming years. So let's just go to this text, just information test. In 2006, Get Hall, frustrated by his manufacturing elevator, decided to take action, leaving the 21st floor, and blah 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 blah. So that we computer people couldn't even make an elevator that works without crashing. That was the point that I was talking. They like he started to blame himself. After all, he was a developer. He can't even fix his problem with elevator. Then why we are saying we are developer? That was the process, the thinking process that gone to his mind when he faced this problem. And this made the fire on him to make a programming language that can fix all this problem at hardware level. So he well aware that C and CPP that was more popular in that time were capable of doing this hardware level logical thinking and all. But the problem with this language was the bugs caused when the problem or program run and the memory bugs that it caused. And this is the final, what can I say? The final stage that caused the program to crash, and he wanted to make a software or a programming language that won't crash or make any memory bugs like C and CPP2. So he was trying to make an enhanced language that can be make more efficient running of programs when comparing with C and CPP. So we can say that, of course, the father of all languages are C and CPP. And his goal was to create a language that would allow developers to write small, fast code without risk of memory bugs. That was the motive of developing this programming language called Rust by this guy. This language would eventually become known as Rust, as Rust is history like Firefox. Uh, take over this project and made this project as an open source, and from that onwards this project get better and better day by day. So that's it about Rust. Okay, I will just going to cover this also, and I know this kind of feel like and talking or teaching you an history section, but yeah, this is the first section. You have to know about some base knowledge about this background of this language. So Rust is an open source programming language, like I mentioned, and particularly it is safe concurrency. It is a low-level statically typed language that offers high compatibility with C and CPP. So as we discussed earlier, the same thing just for documentation, and make excellent choice for a wide range of application for system programming to high-level programming. So that was the main advantages of this Rust programming when comparing with the C and CPP. I mean, at those days, C and CPP were used for all the developing and also system programming. But now the days get changed, new programming language get introduced, and C and CPP, which has high control on low-level access, but when it comes to development first or high level development, we choose other languages like Python or Java. But this is the case that make Rust more unique, and we can also use this Rust programming language for also for development purpose in high level language. So that is the next section is about the features of Rust. So just go through it. I cover some topics of each feature. So zero cost abstraction, error messages, more semantics, threats without data races, guaranteed memory safety, efficiency, binding, and safe memory allocation, safe memory space allocation and minimal time. These are the features that make unique by this language called Rust. So let's dive into more about these features and understand what is this actually the concept and all. So zero cost abstraction in object-oriented concept, we all know about this abstraction, which makes the user feel more comfortable by hiding all the unwanted details from user side and only letting know what they actually needed. Like you see in the picture, there is a child who was going to buy chocolates from this vending machine, and she doesn't even know what is the background work that are going to happen, how this chocolate going to come, how this logic in the behind going to perform when she put some coins inside that vending machine. So this all are hidden, and this makes job of this child very uh, very easy for buying a chocolate. That was simply an abstraction. And when it comes to programming language, it where there are some many other uh, procedures and all how it get implemented. So for now, this is the concept of abstraction and why this abstraction is used as a feature in C Rust programming is that we don't need extra implementation or extra memory to implement this zero cost. I mean the abstraction feature. So this is the just as text as we all know, abstraction is the process of showing only the necessary detail and hiding the rest For example, okay, the example we have already talked, interest abstraction is efficient because it doesn't require extra implementation or memory overhead. That's what I'm talking. So, on other programming languages, when we try to implement this structure, where maybe some procedure like you need extra implementation and some memory need to be allocated for the implementation of abstraction. But we can reduce or we can completely avoid that all implementation and memory overhead on when we're trying to implement abstraction on Rust programming world. So that was one feature, and other one is when comparing to C and CPP and all was okay. This can be error messages. So this only comparable with C and CPP. Of course, we Rust is a low-level language, so we used to compare with C and CPP rather than other languages like Python and Ruby or that. So when comparing with C and CPP, Rust has this complete error message like user will know what actually they are missing and they can fix on that particular error when they get an error. So unlike C and CPP, which provide some ununderstandable, I mean, we don't understand what exactly this error. So in case of Rust, the compiler will provide a more clear idea about the error that we are facing, and it will really help to tackle all the error that we are going to face, because yeah, it is a low level language, so we are going to face a lot of errors in the future when we are going to develop something in Rust. Messages are designed to be clear and concise, making it easier to developers to quickly grasp the issue. So one of the feature of Rust is that all errors are or logical and low level errors are fixed at the beginning itself. So in when we going to compilation time or when we run the program, we don't getting all these similar or head breaking errors like Python and all. So that's all about error messages. Most so without any delay, we can go to the next feature of C, which is sorry, C. Yeah, it will be just overlapping with all languages. So yeah, we can go to the next feature of Rust, which is move semantics. So it is a unique feature that makes this Rust programming language a very efficient or unique one. And the concept behind is very simple. It is an efficient transfer of ownership of the data from one variable to the another variable. So let me just show you. Let me just open my Canva. And yeah, I have this variable uh, 5 in a particular memory location. Let's call this address as 101. And I have this variable num1, okay. And I'm going to create a connection so that I can access 5 using the variable name num1. And yeah, we made a good connection. And if you print this num1, then we will be getting 5 as the output. But in the future, you are, of course, we are developers, right? And we will always make, we have this intensity to make changes. So we decided to change the variable name and create a new uh, accessing point for value 5. So you created num to, yeah, almost identical names. And we made this connection to the pointer 100 memory location 1005, which has this value 5. And now what will happen, or what Rust language will or Rust compiler will do is it will just transfer the ownership of this data, which is 5, from num1 to num2. So the ownership of data is transferred from num1 to num2, and it will break this connection. Now what happens? There is no connection for num1 to access the file, and we can only access this location only using the variable name num2. And this is what a simple semantics concept is all about. So now, for now, this is all you need to understand. And let's move to the theory part, which is ownership transfer. Yeah, that we have already discussed, and safety by transferring ownership. That ensures that there is no dangling pointers Once a value is moved, the original variable is invalidated, preventing any accidental use of free memory. Yeah, this is the concept by there are some uh, vulnerabilities when dealing with C and CPP without implementing more semantics. Like we have this dangling pointer which is pointing to a memory location which is deallocated or get freed. And there are other vulnerabilities like data race related to thread. And yeah, there are many others. So we can avoid this kind of bugs completely by using this move semantics concept. So let's move to the next one, which is threads without data races. Sorry, threads without data races. Yeah, it is also an interesting concept which is implemented using the move semantics concept as the Rust ensures that only one variable is the owner of a particular value which is stored in the data. We can avoid data races. So data races is a occasion when multiple threads try to access this same memory location, and one thread get access to this data, and it will manipulate this data. And yeah, it is going to make some anomalies. So what is this? Let's go to theory. As Rust moves data from one variable to another, the original variable can no longer be used. Yeah, that is we are discussed in the first section. This prevents two threads from accessing the same data at the same time. Okay, this is what data raises. So when if you don't know thread, don't worry, we will be covering all that in the upcoming series. So Rust ensures that you can use threads without running into data races. So that is about that. It all about threads without data races. So you can have to only remember this as threads. Rust ensures that only one thread or one uh, thread will be using a resource at a time, avoiding data races and guaranteed memory safety. Yeah, by doing all that, we will be uh, getting guaranteed that our memory will be saved comparing to other language, and it will be also secure. So it ensures that the programs are free from common memory related errors such as null-pointer dereferencing, as we discussed earlier. When a pointer is pointing to a memory location which is already freed or deallocated. This this situation is known as pointer dereferencing. And buffer overflows. When you try to add some data, more data to a buffer which is already in its maximum size, that occasion or that situation is buffer overflows. And the data races, as we discussed in the last slide, the data races when multiple threads or two or more threads try to access this particular value, and only one get access, and it will change some operations and that manipulate these resources. So yeah, just leave it for now. We will be doing some great videos on that in the upcoming section. And what Rust do will do is avoid this kind of low level errors that makes our uh, overall performance worse. And the next feature is efficiency binding. And you know that this development of Rust is from the idea of C and CPP are not efficient when managing with the memory and all. So efficiency binding means incorporating the features and vast technologies of C and Rust. So yeah, this kind of integrating the language C to the Rust programming language, which will enhance the capability of C. So let's go to the theory section. Like it is not about any practical. You just need to understand all this. So efficiency binding allow developers to combine the power of C with the Rust environment that we are already told, and enhancing the features and capabilities of Rust. Okay, efficiency binding in Rust refer to the practice of creating seamless and performant interface between Rust and C. This allows programmers to call C function and use C libraries, leveraging the strength of both languages. So it is just simple as that. We can just use C functions and libraries within this Rust programming language, which will make these Rust programs much more efficient and more powerful. And yeah, this is the last slide. So safe memory space allocation. As we all implement all this concept, the safe memory space allocation in Rust is one of the language standout feature, ensuring the programs are both efficient and free from common memory errors. Yeah, this is the basic concept that we are already talking from the first place itself. So this makes that if you implement all these features, and the Rust program will make sure that safe memory space allocation will be safe, and also no memory will be pointing to null spaces, so memory will be managed efficiently, which will ensure the programs are both efficient like C and CPP, and also it is free from common memory errors which will do in the case of C and CBP. So that is all about this history and features of Rust. I hope you understand the topic well. And yeah, in the upcoming videos, we are going to more practical oriented videos. And yeah, of course, I know it's kind of boring video because yeah, all hate to study about theory and features and all stuff like that. Even I also hate, but yeah, of course, for your knowledge, you try to read all this document, and I will provide this slide in the description, and you can go some browsing based on the headlines. And yeah, try to understand what makes this Rust programming language different from others. Yeah, so this is it, and I'm stopping this video. Thank you for watching, and